Welcome to Worst Case Analysis using Mathematica. This section is going to be how to turn our solution into a report. So we're going to start with the KVL solution. This is brought to you by Right Paradigm Consulting, and I'm Jay Oplinger, the author. So the nice thing about Mathematica is once you've done the analysis, now you can go back and document it up, add text, add pictures, add things like that. So we'll start by putting a heading on this, and I'll be lazy. I'll just replace the one here with one I've already cooked up. It's called Worst Case Analysis Report. We'll get rid of this KVL solution. Or first, I think what we'll do is let's go down and we're going to hide this function that's here by creating a section in the document. So we'll go up to Format, go Style, and call this a section. And then we'll type in the section, we'll call it Function. Now that's a little bit larger, so let me change that to a subsection, because that's all we need. And now notice that subsection is going to encompass all the way, we want it to encompass all the way down to here. So now we'll go in here and we'll say Format, Style, and we'll call this a section and type in the circuit. Now notice that the line breaks here will allow us to double click on this function and in essence hide it. So in this way we can hide our homemade function, and the downward arrow here shows that there's something hidden under here. But most people who are like reading the report are not going to be concerned with what function we use to create this. Now, in a lot of cases, we'll get rid of this. In a lot of cases, you might have the schematic available, using a circuit design program, or you can sketch it out and scan it in and paste it in here. And the way you do that is you would highlight it and go Insert Picture from File, and then go to the file you want to insert. Now we want to jazz up this writing loop equations, so we'll call that a subsection. Format, Style, Subsection. And now notice that looks a little bit better in terms of making a report out of it, another header. And we can do the same thing for all these other pieces. Style, Subsection. This just makes it look a little bit more professional. Style, Subsection. So, for example, once you have this, maybe even prior to putting the circuit down here, you could actually add some text and describe what this circuit does and what its place is in the whole scheme of things. So you would go up here to Format, Style, and go to Text, and then you could type some text in. Circuit does something. Okay. You can write a detailed explanation in here of what this circuit does and why it's important. Now, Again, what we're going to do is we're going to call this another subsection, and we're going to say this is solving for the transfer function. And then that gives us the inputs and the outputs. Now, once we have that, then we want to describe, and again, anywhere in here you can add text. So let's look at the sensitivity analysis. All we're going to do is change the formatting to a subsection. And now we want to add in a discussion of what the sensitivity analysis is. So I'll be lazy and I'll just copy and paste from some stuff that I've already written. Again, to do this, you would just highlight that section, go up here and say Style Text. And then we go through those sections. And let's move this down here to here it is. Now we're going to make another subsection here called finding the transfer function and plotting the Bode plot. So that makes another section. Now, one thing to notice, let's go up one section again, go back a little bit. If you don't particularly want to show somebody the sensitivity analysis information, you just go to this second grouping. Notice how it takes this whole group together, and if you double click on it, it collapses it. You can tell by this little arrow, and actually in the latest versions of Mathematica they have these arrows here to show you something's collapsed. So you can either leave those in the report, the descriptions, or you can hide them in a sense. So now we're going to find the table, the transfer function. Now, let me take a pause and go back and execute these functions. So now we want to look at the Bode plot itself. And we would like to, let's say, jazz it up a little bit. So what we're going to do is, so we end up with two different colors here because we have a minimum and a maximum. We're going to change how we input this by selecting either the first one here, comma, or we can copy and paste this. Edit, copy, paste, put a 2 here. And then when we plot this, there'll be two different colors, which would help somebody looking at this. Now we also want to put a frame around it. So we'll type the name frame true. And I like grid lines. So we'll type grid lines automatic, comma. And then we're going to change the axes label to frame label. Oops, I don't need label twice. And then let's also put a plot label in there. And just call it Bode magnitude plot. And now let's execute this and see what it looks like. Now this looks like a much more professional plot because it has axes on it. It looks like it's actually graph paper, and it's enclosed. I can make it bigger just by grabbing one corner so you can get a closer look at the different values. And notice it has nice labels on the horizontal and vertical axes. Now, something else we might want to do is provide a phase plot. So I'll put in the function there to do that. So here's the function that we can get the Bode phase plot from. Notice I've changed the arguments to 180 over pi, which converts it from radians to degrees, the argument of h of j omega, 1 and 2, and then changed the labels. So let's execute this, and now we can see what the Bode phase plot looks like. Notice it runs from 0 to 180 degrees. Now the last thing we'll look at is how we jazz up the time domain plot. And right here we have these tiny little numbers and a plot that doesn't have any grid lines on it. So let's do a few things here. We're going to look at each individual function, 1 and 2, the upper and lower limits. And we're going to change the time variable from time. Let's do this to the minus third. Which would be in milliseconds. And we're going to run this from 0 to 1 millisecond. Now, since we changed those variables, we'll change this time to milliseconds and the output voltage. And the plot label will be step response. Now, we do need the frame and the grid line, so let's put that in here. Frame, true, grid lines, automatic. Now it looks much better. And then we can make that larger as well. So now we can actually shrink this down a little bit. Let's make it from 0 to 0.2 milliseconds. So now you can see the rise time. The time's in milliseconds, so they don't look quite as small. And you have both a minimum and maximum, so you can look at what the overshoot is in both cases. Now the final thing to do when you're writing a report is you usually want to write a conclusion. So what you would need to do is then go up here to Format, Style, say Section, go Conclusion, and then type some text that describes what your conclusions are about this circuit and how it's worked. So that in a nutshell is how you take the analysis you've done and then convert it into a finished report. So we look forward to talking to you next time when we'll take a look at a nodal equation circuit problem.